Hello everyone and welcome to this video. Today we're gonna cover C++ basics and we're gonna cover data types and expressions. And so let's get started. As you can see, so there are different data types and expressions. And so 2 and 2.0 are not the same number. They are a different data type. A whole number such as 2 is a type of integer int, whereas a real number such as 2.0 is a type of a double. Now, numbers of type int are stored as exact values, while numbers of type double may be stored as approximate values due to the limitations on number of significant digits that can be represented. So they could be stored as approximations or an exact value if this value is provided. And so writing integer constants. Type int does not contain decimal points. That's a fact. That's why it's called integer. And so there are some examples. Now, writing double constants. So you should type first double, which is a keyword, and then there are the symbol form, which is any form that includes a decimal point. And so there is also the floating point notation, which is the scientific notation, which includes e to the power of 1, like 10 to the power of 1, 10 to the power of 5, etc. So examples of this is this 3.41 e to the 1. This is basically times 10, 3.41 times 10, so 34.1. This number, 34.1. And so e is just 10 to the power of something. And so the number left of e does not require a decimal point, that's a fact, and then the exponent cannot contain a decimal point. The exponent should be an integer. So there are other number types, okay, and these require different memory requirements. So more precision requires more bytes of memory, and very large numbers require more bytes of memory, very small numbers require more bytes of memory. These both require more bytes of memory. So the more precise, the more you will need bytes of memory. The more precise the number, the more bytes you will need of memory. And so there are the integer types. There is long or long int. This is often 4 bytes, which is equivalent form to declare very large integers. And so long big total and long int big total are the same. And there is also short or short int. This is often 2 bytes. So this is equivalent form to declare smaller integers. So you can say short small total, for example, or short your variable name, or short int your variable name. And so there are also the floating point types. So we have also long double. Okay, so this is often 10 bytes. Okay, and the byte we say is 8 bits. 8 byte, 2 bit. This is just, sorry, 1 byte, 8 bits. 1 byte is 8 bits. Okay, and the bit is the smallest. And so this is often 10 bytes, which is 80 bits. So, and declares floating point numbers with up to 19 significant digits. Okay, 19 significant digits, which is a large amount. And so long double is a big number. Now float is a smaller one. It's often 4 bytes, which is 32 bits. Declares floating point numbers with up to 7 significant figures. So it's like a double, okay, but it declares a variable or a floating point number, okay, a number with a digit or a floating point, so like decimals, with up to 7 significant digits. So float, not so big number, as you can see. And here are the numerical data types summarized. Okay, first we have short. For short integer, the range is -2 to the 15. 2 to the 15 is a very big number, okay, or it's in the thousands, okay, so minus 32,000 to 32,767 exactly. So, and the storage size is just 16-bit signed or 4 bytes. And then there is also the unsigned short end, okay. So, and this goes from 0 up to 2 to the 16. So this is without the sign, there is no negative sign, only a positive integer. So to use it, gonna just write unsigned short int. So 16-bit unsigned. Now we have the regular integer, which is signed. It goes from minus 2 to the 31. This is a very big number, to this number, which is 2 to the 31 also. And this is 32 byte, which is 4 bytes. Sorry, this is 2 bytes, and this is 4 bytes. Now there is unsigned int also, which goes from 0 up to 2 to the 32. There is long integer, so it goes from negative 2 to the 32 to 2 to the 31. It's like the integer, but this is this floating point. Oh no, actually this is an integer. It's 32 bytes signed. The first one was unsigned. The int itself is just signed, okay. It's unspecified, so it's gonna be signed. The unsigned int is just an integer with no sign, so it's just a positive integer. Long is signed, okay. Now there is unsigned long. Unsigned long is just only the positive part, and there is then long, which is a very large number, minus 2 to the 63, negative up to 2 to the 63 also in the positive. And this is a 64 byte sign. This is like 8 bits. It's a very large variable. And then we have float. So float ranges from this number, okay, to negative 1.4, and then this number. Then there is the positive range, which ranges from this up to this. This is the positive range. So this is a 32-bit IEEE 757. There is now the double. Negative range goes from here. Okay, so it includes also the 0. Yeah, it includes from the positive up to the 0.000. So this is 0.000, like 45 zeros. This is like the positive range, as you can see, negative range, positive range. It's interesting to know these values. And then there is the long double, which is very large, way larger than any of the rest of the data types, which is an 80-bit 10 bytes. Now there is the size of function, which can be used to find the size of a type. So examples, COUT, then insertion operator, size of integer, int, and then you can write also size of long, and these are just, they output the size of each of the keywords, like the integer, long, and double. So integer is just 4 bytes, long is 4 bytes, and double is 8 bytes. Bytes, not bits. And so double area equals 5.4. Okay, and so the size of area is just gonna be 8 since the double. Okay, and size of just returns how many bytes this variable is. And so it doesn't return anything related to the value itself. Now there is also type char, okay, which is short for character. okay, so short for character, and can be any single character from the keyword. And to declare a variable of type char, you just say char letter, and then you can equate it to any letter in the keyboard. And they are constants, so character constants are enclosed in the single quotes, so character letter equals a, and strings of characters even if only one character is enclosed in double quotes. So a is a string of characters containing one character, and also a is a value of type character. So this is a string that contains one character, but when we use a single quote is a value of type character. So it's important not to use or mix between them, since in Python, for example, for those who talk Python or know about Python you can just switch them at any time, and there is nothing called character there, it's just all strings. And so, but here in C++, no, if you're gonna use single quotes, you're gonna use it for a character only. Double quotes are for string. Yeah, sequence of characters, which is a string. So, reducing character data. So CIN skips blanks and line breaks looking for data. And so the following code reads two characters but skips any space that might be in between. So now we define char, symbol 1 and symbol 2, and then CIN extraction operator, symbol 1, and then extraction operator, symbol 2. And then a user normally will separate data items by spaces. And even if separated, the result is going to be the same. If it's separated or not separated, the separation doesn't matter. What matters are the characters. Now we have type string, of course. String is a class different from the primitive data types discussed so far. So string is a class. And the difference is going to be discussed in chapter 8. And so for a string, you're going to use double quotes around the text to store it into the string variable. And it requires the following to be added at the top of the program. So include string. And to declare a variable of type string, you're going to just write the class string, and then the variable name, for our example is just name, equals the variable name, which is the string. And now there are type compatibilities. So in general, you store values and variables of the same type. So, and as you can see, this is a mismatch, and it may reduce an error, or it might be rounded down. So it's an integer, and here we are assigning a double. So if the compiler allows this, if it allows this, this is gonna be most likely contain the value 2, not 2.99. So it's gonna floor it down. And so variables of type double should not be assigned to variables of type n, as you can see. So double variable is 0.0. We cannot assign variable of int type to a variable of double type. And if this allowed, if the compiler allowed this, int variable will contain 2 and not 2.00. And integer values can normally be stored in variables of type double, as you can see. So double variable equal to 2. Integers can be stored, okay, and double variable will contain 2.0, but the opposite cannot be true. So integers can be stored in the double, but a double cannot be stored in an integer value. Now let's talk about typecasting. So there is implicit casting. So double D equals 3. And there is explicit casting, which is int I, static cast int 3. As you can see, C style casting fraction part is trans. And so casting does not change the variable being casted. So double D equals 4.5, and then we have int I equals static cast integer D. Now this is our variable, and D is not changed, of course. It doesn't change the variable being casted, as you can see. So static cast int 3. So it just narrows the type. So basically this converts from a double into an integer. So it changes this double so it can be stored inside an integer variable. Now if we want to switch between a character and an integer, it is possible, but generally not recommended. And so it's possible to store character values in integer variables. You can do that. It will contain an integer representing A. And it's also possible to store int values in character variables. And so char letter equals 64. And then, so the letter will contain the character represented by the integer value 65, which is A, basically. So this is possible, but it's not recommended. And this is the ASCII table. And this is basically represents all the letters, all of the integers representing the letters. So for A, we said we have it as 65. So when we add 65, we're gonna get the letter A here. For A, we're gonna get here 65. It will contain an integer which is 65 representing A. And that's basically the table. Now, there's also type bool, which is boolean. So the following actions are possible, but generally not recommended also. So values of type bool can be assigned to integer variables. So true is stored as 1 and false is stored as 0. And values of type n can be represented to bool variables. Okay, and so any non-zero integer is stored as true, and any zero integer is stored as false. Now there is arithmetic, which is performed with operators. The plus sign is for addition, minus sign for subtraction. The star is for multiplication, slash for division, and the percent sign for modulus. And so storing a product in the variable total weight, as you can see, is one weight times number of bars. And so the results of operations can be used with any numeric type. Arithmetic operators can be used with any numeric type, and an operand is a number or variable used by the operator. And so the result of an operator depends on the types of the operand. If both the operands are int, the result is int. If one or both operands are double, the result is a double. So if you multiply double by int, you're gonna get a double at the end. Double by double is a double. Now division of doubles. So division with at least one operator of type double produces the expected results: double divisor, dividend, and quotient. So the divisor is 3, dividend is 5, the quotient is dividend over divisor. So here we have integers, we have doubles, 5 over 3, the quotient is 1.6666, and the result is the same if either dividend of divisor is of type int. If they were both of type int, the result is gonna be the same, 1.66. So if it was an integer, one of them, we're gonna still get the quotient as a double. Okay, I think we're gonna stop here, division of integers, and we're gonna continue in a different video. Thank you all for watching. I hope you benefited from this video.